Good afternoon, Year 11s. So this is for my class and Ms. Chen's class as well. Just wanted to make a point here. One of my students also sent me a question about this, so you can really thank that student for bringing that to my attention to give you guys a little bit more information. Okay, so when you're looking at your transpiration experiment and really also your task 4, okay, you need to remember that you can only change one variable at a time. And if we stick with the theme I was working with this week and using the experiment of how long does it take for a leaf to go brown, I would be testing two different independent variables, and let's just say different species and under different types of light, in order to increase the complexity of that experiment. Now, if I change both of those variables at the same time, I wouldn't be able to attribute the result to either variable because I don't know which variable, species or different light, actually influence the leaf to turn brown quicker. So this wouldn't be a fair test. And another way or another example to explain it, if you were, for instance, last week, or all the time actually, if I make banana cake, I can't make it like my mum used to make. And I think it's because I put too much banana in. But I also usually try and put a bit more bicarb soda in to make it rise a little bit more. Now in this instance, I've probably changed from my mum's recipe. I've added more banana in and I've added more bicarb. And the result is it kind of goes flat, a bit more like a slice, and not like domed like a cake. But I don't know which one of those two ingredients is making it go like this. So in order for me to find out, I'd have to only change one at a time. Okay, so I could reduce the amount of banana I put in, but keep the same level of bicarb, or I could leave the same amount of banana and reduce or increase the level of bicarb. Okay, that way, if I do see it rise properly, like a mound, like a normal cake, then I know exactly which one of those variables had that result. Okay, so in any of your experiments, and this is across the board, you can only measure one variable at a time. And so as an example, like I said, with how long does it take a leaf to go brown, to resolve that issue, we must only change one independent variable at a time. And this will involve a number of different experiments in that case. We can't just get it done quickly. So for example here, I might have 3 trials. Okay, so each one of these trials is going to be changing the different types of light. So I'm only changing one independent variable between trial 1, trial 2, and trial 3. This whole time, I will be using wattle leaves. Okay, so I've only changed one variable. And I'd also do that in 3 replicates. I'll do that experiment 3 times. Because that trial there by itself, okay, would give me information on how long it takes the leaf to go brown under different light conditions. I would have a result for that, but I don't have a result for different species yet. So what I need to do, I need to change the different species, okay, which I have here, but I still need to keep my types of light the same. So I'll need to repeat UV, sun, and white light again, but with gum leaves. You could possibly leave it there and just do 2 different species. Again, it's a bit like the replicates. You're better off having 3. So in this case, I've done paper bark, okay, and I've done 3 replicates each time as well. Okay, so you can see there you're going to have quite a lot of different trials to run through. I think you'll have 3 times, about 27 different ones you'll need to run through. But as I was telling my class, you're going to have 27 different results, which means you have a lot more data, you have a lot more data to graph, you have a lot more data to tabulate, you have a lot more data to discuss, and because you've used 2 different variables, you have something to compare as well. Okay, you can start forming those interrelationships between the species and between the different types of light. So I've given you a good little heads up an example here. We've done that for the simple reason that it's year 11. Okay, this is your chance to make mistakes, and it's your chance to learn. So looking forward into year 12, you wouldn't get an example like this. Okay, you would be expected to move forward by yourself, okay, and remembering these rules of one variable at a time, okay, and expected to design your experiment pretty much by yourself. Okay, so like I've said, use your year 11 as a time to make mistakes, learn from them, so next year you can put it all into place. If you've got any more questions, my class, you can email me, Mr. Ten's class, just send him an email. See you later, guys.